We will start today's class and I will be discussing about circular chart and LVDT in this class. So let us come to the first one, XY recorders. These instruments are employed where it is desired to plot the relationship between two variables. Instead of plotting each variable separately as a function of time, for example, y is equal to f of x. So, these recorders have a special capability of displaying two separately varying quantities on the x and y axis of Cartesian coordinates. In such a recorder, one of the variables is applied to the x input and the order to the y input, and the recorder plots their variations against one another. An XY recorder closely resembles and functions like a single pen recorder, except that the chart is moved in response to changes in a variable instead of a uniform time rate. In such recorders, chart remains fixed in its position and the pen moves simultaneously in both the x and y directions in response to electrical signals applied to its two input terminals. As most of the XY recorders also have a time base, so they can be employed to plot the variation of one variable against time as well. Thus, such recorders carry out some measurements in the same way as the strip chart recorders do. Normally, XY recorders use pen and ink marking system and ordinary low-cost paper for the chart. The pen assembly is a refillable reservoir with a long bent tip, or it may be a cartridge type one. The mechanism for the movement of the pen in both the x and y directions is a closed loop servo system, which is quite similar to the servo mechanism employed in self-balancing potentiometer. The rotation of the servo motor moves the marking pen with the help of a string and pulley arrangement. So, what are the advantages of XY recorders? They have, or that they are rather economical to operate as ordinary low cost paper, can be used for the chart, and they are easy and convenient to use. The disadvantages of XY recorders are that in comparison to strip chart recorders, they are more expensive to buy and cannot be employed for continuous recording because of electromechanical mechanism used for the movement of pen. The frequency response and speeds of XY recorders are inherently limited. So an XY recorder may have the sensitivity of 10 microvolts per mm, slewing speed of 1.5 meter per second, a frequency response of about 6 hertz in both the x and y directions, and an accuracy of plus or minus 0.2% of full scale. So the paper size used in these recorders is 440 by 280 mm or 280 mm by 220 mm. So input impedance is from 100 kilo ohm to 50 mega ohm, or more depending upon the sensitivity range. So coming to the circular chart recorders, these recorders were developed mainly to take advantage of the availability and convenience of spring-wound clock and synchronous motor movements to drive the chart in a circular direction. So you are seeing here circular chart coordinates. In this recorder, a circular chart is used which has concentric circles ruled on it to form its scales. In addition, there are printed arcs extending from the center of the chart to the paper's edge. As the pen of the recorder is moved, it swings along these arcs. The arcs are called time arcs. The speed of rotation of chart is usually 1 revolution per 24 hours or per 7 days or any other speed which can be conveniently obtained by using synchronous motor with suitable gear assembly. The radial position of the pen at any time indicates the instantaneous value of the quantity under measurement. Circular chart recorders are particularly used or suitable for direction actuation by a number of mechanical sensors such as bellows, Bourdon tubes, etc. Magnitude of several variables can be recorded on a single chart, which makes it easy and convenient to analyze the interrelationship of various measurements, and also it saves the panel mounting space. Chart diameter is limited to a maximum of 0.3 meter. Speed of the chart is also limited. Resolution along the scale length is usually non-uniform and the charts do not run for a long period. So let us come and discuss next type, that is LVDT, linear variable displacement transformer. Is a sensor module implemented to transform the input variations or mechanical motion into input vibrations or mechanical motions into variables. Electrical signals or electrical current and voltage. What you are looking at the diagram is LVDT. Very important one. I think you might have studied, you might have gone through it, or you might have studied earlier. What is this LVDT? So coming to the construction, the structure of LVDT is similar to the inductive transformer. It comprises two sets of solenoid coils, namely primary and secondary coil, lined end to end, covering the core. The primary coil is connected to the input AC power supply and placed at the center of the core. The secondary coil consists of two secondary windings which are at the top and bottom of the base with an equal number of turns wounded on a hollow cylinder. The overall behavior is evaluated in terms of linearity and robustness. This is about LVDT, and which is very important from exam point of view.